This is Chem 108. Today is March 17th, 2015, and we will continue on in Chapter 4. Okay, so ahead of your exam, we're going to do some more practice problems. Right? We covered all the material, but we're going to do some more practice. So the last thing that we did last time was acids and bases and acid-base reactions, and so let's try a problem. And let's say we're reacting 0.025 molar BaOH2 aqueous. And we're doing a titration, and that's what we have in our burette. Okay, we have 0.25 molar barium hydroxide solution. So if you're doing a titration, what you're doing is you have one reactant. You know the concentration. You've made that. You've prepared that yourself, or you've bought it from some reputable source. But you know the concentration very well. And you're making a measurement of the volume. Volume times concentration gives you what? Moles, right? Volume times concentration gives you moles. So once I have a volume of this and the concentration, I can find out moles. And I don't know if you noticed this, once you find out moles, you can find out anything, right? Once you find out moles, you can find out molecular weight. Once you know moles, if you know the mass, you can find the molecular weight. If you know moles, you can find out something about concentration or volume. Right? If you know moles, you can find out something about, just reaching back into Chapter 3, you can find out something about the number of atoms and the number of molecules. If you have a balanced equation, once you know moles of one thing, you can find out moles of the other thing. Right? So once you know moles, you're on the way, almost always. Okay, so you have, this is your titrant, and let's say you have 71 grams of HCl. Now HCl, we usually don't measure in grams, but for the sake of this problem, let's measure it in grams. I mean, because HCl is either a solution or a gas, but we can measure it in grams. It's not a problem. So 71 grams of HCl, and where we want to find out, what do we want to find out? Sorry? Yes, moles, but the final thing we want to find out is the volume, right? In this case, what volume of the BaOH2 is necessary to completely react with the 71 grams of HCl. So the first thing we want to do, I think, well, I know what I think. You tell me what you think. What's the first thing you want to do? Write the equation. Excellent. That's the first thing I would do. So what's the equation? HCl, aqueous in this case, plus BaOH2, aqueous, gives us H2O, right? It's a, what kind of reaction is this? Right, what's kind of neutralization, right? BaCl2, right? Because it's 2 plus and 1 minus. We got to do our crossing over. BaCl2. Is that soluble or insoluble? That's soluble. And is this good? Got to balance. And I think what we got to do is two of these and two of these. If you don't know the chemical equation, better find out what the chemical equation is. Otherwise, you're just kind of groping in the dark. Right, so what volume? OK. So where do we want to start this? Molar mass of HCl. The molar mass of HCl together with the mass of HCl is going to give us moles. Right, so the molar mass of HCl, H is 1.0079. Okay, and Cl is 35.45 something. 3? Okay, and we add that together, we're going to get 36.4 46094. Okay, so 3 decimals 461. Okay, grams per mole. So HCl has a molar mass of 36.461 grams per mole. And so we had been making these kind of like flow charts, right? So we're going to start with mass of HCl, and then we're going to go to moles of HCl using the molar mass. Where's the next place where we're going to want to go? Mole ratio, coefficients. We want to get moles of BaOH2. And we're going to use the mole ratio or the coefficients. And then once we go to moles of BH2, what do we want to get? Volume, right? In chapter 3, once we got to moles of something, we were finding mass or we were finding molecules. But here we want to go to volume of the BaOH2 solution. And we can find that using how do you relate moles and volume? Molarity, concentration. So big M or molar concentration or big capital M. So where are we going to start? We're going to start with the mass, 71 grams. And I'm going to say we've got molar mass. What goes on the top? What goes on the bottom? 1 mole goes on top, and 36.461 grams goes on the bottom. And although you don't have to do this, I like to do it. Grams of HCl per mole of HCl. Right? And so when we do that, we're keeping track of something, right? We're keeping track of exactly what chemical species we're thinking about. Okay, so I used the molar mass. Right? I took this and I hung it over here. Right? This is our molar mass. What's next? Well, we're going to use our coefficients. And our coefficients are 2HCl. That goes on the top or the bottom? Bottom. HCl, right? 2 moles of HCl reacts with 1 mole of BaOH2. And so now we take our sign over here, right? Hang it over here. Coefficients. And now we got moles of BaOH2. Once we get moles of BH2, what do we want to do? We want to convert that to volume. And so this, remember what I said big M means. Big M means moles per liter. Moles per liter. how can I get liters volume out of 0.025 on the bottom, because that's 0.025 moles of BaOH2 per 1 liter of BaOH2. The moles and the moles cancels, and now what do I have? Liters. That was our, take this sign over here, move it over here, molar concentration. And when I do that math, has anyone done that math? 38.945, we've got 2 and 2, so we've got two significant figures. So 39 liters of BaOH2. That's a very large titration. But it makes sense because, okay, it makes sense. Okay, 39 liters of BaOH2. Questions? Let's keep the same equation here, and let's change the problem a little bit. So now we have same solution of BaOH2, and we are reacting, and we have 37 milliliters of it. Okay, so we have 37 milliliters of 0.025 molar BaOH2, which reacts completely with 22 milliliters of HCl, aqueous. Okay, so take a look at the problem. We've got this concentration of BaOH2, and we've got 37 milliliters of it. That 37 milliliters reacts completely with 22 milliliters of HCl, aqueous HCl solution. Can you tell me what question I'm going to ask? Concentration of HCl. That's right. Find, remember these square brackets means molar concentration of HCl. That's what those square brackets mean. So put your heads together gently and give it a try. All right, so we've got something that we know and some things that we don't know. Right, so what we know is something about the concentration of barium hydroxide and the volume of barium hydroxide. And if I know the concentration and volume of the same thing, that means I can find moles, right? And once I find moles of one, I can use the coefficients to find the moles of the other. Right? In the previous class, I told you, the moles of acid equals the moles of base. That is true in a certain sense, but in this case, we have another factor to consider, and that's the coefficients. Right? So let's start with what we know. Right? So we've got 0.025 big M. And when we see the big M, we think moles per liter. Right? And then I'm going to do this conversion in my head. 37 milliliters is 0.037 liters, right, if I want over 1. And this is moles of BaOH2 and liters of BaOH2. And the liters are going to cancel and give us moles of BaOH2, right? If I wanted to do this instead, this is correct, but I'm going to write it out the other way. I'm going to write it this first. 0.025 moles of BaOH2 divided by liters of BaOH2. Right, I'm just changing the order of the multiplication. So the liters and the liters cancel, I get moles of BaOH2. Now what do I need to do? I need to look at my chemical reaction and think, okay, 1 BaOH2 reacts with how many HCl's? 2. I'm going to use my coefficients. So 1 mole of BaOH2 reacts with 2 moles of HCl. Moles of HCl. Now, if I want to, once I have moles of HCl, what do I want to do next? Well, I want to find out the molar concentration, which is moles per liter. And so, okay, so if I want to find out that, what am I going to do? I have moles. What do I need to do to get moles per liter? Divide by liters, right? And so that's 22 milliliters. It's divided by 0.022 liters. And that's going to give me moles per liter. And I believe the answer is 0.084 moles per liter, or if you want, 0.084 molar. Questions? As I was going around the room, a lot of you got that, and those of you who didn't get it at least had some idea of the way in or something. So this is a kind of a good sign. You disagree? Okay, so let's take one step back in time and go and do this. Let's say we have, no, let's not do it that way. Let's say aqueous solutions of iron 2 chloride and ammonium sulfide are mixed. Tell me what the question is. Sorry?
If there will be precipitate?
Okay, so one question could be, will there be a precipitate? That's a pretty good question. Let's ask a more comprehensive question. Write the molecular formula, the net ionic, the complete ionic, and the net ionic formulas. Identify spectator ions, right? That's kind of the comprehensive. Identify the precipitate, or is there a precipitate? And so, let's say, write molecular complete ionic and net ionic equations, or write the equations for the complete molecular ionic and net ionic reactions with states identify the precipitate and any spectator ions. Go for it. All right, so I like it. So most of you, a lot of you seem to know how to do this. Some of you forgot what sulfide is. Some of you forgot what ammonium is. Those things you need to remember. But once you got that clear, a lot of you were able to do this. So what's iron 2 chloride? FeCl, right? So FeCl2. So FeCl2, aqueous, plus ammonium is NH4 plus, right? NH4 plus. Sulfide is S2 minus. So it's going to be 1, 2. So it's going to be NH4, 2S. Aqueous. Results in, you do the exchange. FeS. We're kind of lucky here. You may not be so lucky on your exam. 2, 2, right? And so that reduces to 1 and 1. What's the state?
Solid.
Solid. What's the rule for sulfides? Right, so they're insoluble except when they're combined with group 1 and ammonium, because everything is soluble when it's combined with group 1 or ammonium. Plus, what's the other one? NH4 Cl. So plus 1 plus minus 1, 1, 1. Right, so why are you lucky? You're lucky because there's no superscripts, right? Subscripts. And that's aqueous, right? Because ammonium salts are always aqueous. So that's your molecular equation. And then your ionic equation, your complete ionic equation, you're going to break these into, oh yeah, you got to balance it. So we've got a 2 in front of the NH4, and that's it. Yeah. Awesome. Okay, so we've got Fe2 plus, aqueous, plus Cl minus aqueous, plus, no. Now here's where you stop me and say you messed up. 2, thank you, plus 2 NH4 plus aqueous, plus S2 minus aqueous, results in FeS, solid. This is your precipitate. Plus 2 NH4 plus aqueous plus Cl minus aqueous. Two Cl, yeah, because the 2 goes with the whole thing. So what are our spectator ions? No. 2Cl and 2 NH4. NH4Cl. So the net ionic is Fe2 plus aqueous plus S2 minus aqueous, results in Fes solid. Questions? What's that?
No, I'm just saying I would love this question for limiting reactions.
Well, you will get something like this, but for sure. I mean, it's not. I don't think it's a big secret. I'm not spilling any. You'll get a question like this. You probably won't get this exact question. Other questions here? Okay, so how are you all feeling? Tired? You want a break? All right, let's take a break. 10 minutes, and then we'll do some more problems. So during your break, what I did is I erased the complete ionic and net ionic equations. I left the molecular equation, and now we're going to use the same equation and do some math. And so I've got 0.10 molar FeCl2. I got 0.15 molar NH42S, right, ammonium sulfide. So I have two, now instead of just kind of like this generic equation, I'm actually saying, okay, I've got this, and then 1.4 liters of this solution is mixed with 1.1 liters of this solution. Find the mass of FeS produced, find the concentration of NH4Cl, find the moles of excess reactant. So the moles of excess reactant tells you that this is what kind of problem? Limiting reactants. So limiting reactants, we haven't done limiting reactants with solutions yet. But it shouldn't be impossible, because what do you need to do? You need to get from something to moles. Once you get to moles, it's the same. So what do you want to do? How are you going to do this? So it's limiting reactants, so I'm going to ask the same questions. I'm going to ask, I'm going to use a little more board, so I'm going to say, how much product and in this case, the first question asks about the FeS, right? So I'm going to say how much product, and I can pick either one. In this case, I'm going to pick the FeS. How much FeS can be made if all the FeCl2 is used? And then what's the second question I'm going to ask? How much product, in this case, again, FeS, can be made if all of the NH42S is used? And once I answer these two questions, how do I determine the limiting reactant? The smaller one. Okay, so I've got liters and moles per liter. If I multiply liters and moles per liter, what do I get? Moles, right? Liters, moles per liters gives me moles of FeCl2 or NH42S. Once I get moles of one of the reactants, can I get moles of product? Yeah. So what am I going to do? I'm going to start with liters, right? So 1.4 liters of FeCl2 over 1 if I want. And then what's next? Moles per liter, right? So that's 0.10 moles of FeCl2 per liter of FeCl2. And so the liters and the liters cancel, and I'll get moles of FeCl2. Except I'm not really interested in the moles of FeCl2, at least not at this point. What do I really want? How much product can I make if I use all of this? In this case, the coefficients are all 1, so doesn't really, the math doesn't really matter, but I'm going to have 1 mole of FeCl2 produces 1 mole of FeS. Right, and that's going to give me 0.14 moles of FeS can be produced or can be made if all the FeCl2 is used. Now I'm going to check the other one, right, the other reactant. And the other reactant says is 1.1, right? 1.1 liters of FeCl2. Nope, wrong, I lied. NH42S. And the concentration is 0.15, right? So 0.15 moles of NH42S per liter of NH42S. The liters and the liters are going to cancel. I'm going to get moles of NH42S. I'm not really interested in the NH42S at this point. I'm going to say, but I'm going to convert that from 1 mole of NH42S to moles of FeS. And that's going to give me 0.16, is that correct? Okay, 165, okay. So 0.165, or to two significant figures, 0.17.
No, it's 1.65. Yeah. It's 0.165.
0.165 or 0.17, yeah. Moles of FeS. Right. So, which one is the limiting reactant?
FeCl2.
The one that gives me the smaller amount of product is the one I run out of first. Right? And so the smaller amount of product is FeS. Now don't go telling me FeS is the limiting reactant by accident. You want to go back here and tell me the FeCl2 is the limiting reactant. I still haven't answered any of my questions. But we're about to, right? So the mass of FeS produced is going to be the mass of FeS that comes from this amount of moles of FeS. I don't have to do that calculation again, right? So I'm going to go and say the mass of FeS is going to be 0.14 moles of FeS. How am I going to get the mass? Molar mass. The molar mass, Fe is 40 something, right? 55.85. And S is 32.0 something, 07. And so that's going to be 0.92, 87.92 grams per mole. What do I do here? Grams on top, 87.92 grams per mole. Moles and moles cancel, and I'm going to get something. Somebody have an answer?
12.30.
12.30, or actually just 12 grams of FeS. Once we did this part was not too bad. Okay, ow, sorry about that. Don't listen to that with your headphones on. NH4C, concentration of NH4Cl. How do you want to do that? Yeah. Yes. Okay, so we're going to get moles over liters. How are we going to get moles, and how are we going to get liters? Almost. We almost have the moles. Right, so we have this amount of moles of product, which we can use, or we can find the moles of reactant. We can use that too, of the limiting reactant. We have the moles of product, so let's use the moles of product. We can't use that moles directly. Why not? Because 1, 2. So if you made 0.14 moles of FES, you used 2 times that. So we're going to say we have 0.14 moles of FES. 1 mole of FES gives me 2 moles of NH4Cl. Okay, so we get our moles of NH4Cl. How do we get our liters? But we're trying to find out the molarity, right? The square brackets is molarity. So if we have moles and liters, we can get molarity. But where do we get our liters from? You're looking at it, I think. Okay, so someone read the question again. No? No? 1.4 plus 1.1. Right, you mixed one solution of 1.4 with one solution of 1.1. We assume when you mix them, they add. Right, so the total volume is going to be 1.4 plus 1.1. So it's going to be divided by 2.5 liters, which is 1.1 plus 1.4. And so that's going to be 0.11, is that right?
Wait, shouldn't you flip it? Shouldn't liters be on the top?
It's moles. Molarity equals moles over liters. Right, so the moles is on top, and the liters is going to be on the bottom. 112 or 0.11 moles per liter, or 0.11 molar. So, I mean, I'm giving you some different examples. There's really like 10,000 different ways you could ask these questions, you know what I mean? And we can't go over every single configuration. But once you start once you've done 10,000 problems, right, you can start to see, okay, moles, liters, moles, everything goes through moles, right? Once you get the moles, once you have moles, you get to concentration using the volume. You get to volume, you can get to volume using concentration. Okay, so, questions? The moles of excess reactant. So which one is, so this is excess reactant after the reaction occurs, right? So how do we find our excess reactant again, or how much excess reactant is left? You start with the limiting reactant, right? You find out how much of the excess is required to react with the limiting reactant.
Don't you do coefficients?
You do coefficients, right? So remember, so here's your bread, right? Right, here's your ham. Right? 2 breads and 1 ham make a sandwich. Which one is limiting? Bread. Bread runs out first. How much is left? 2. How do we figure, you can figure it out because this is bread and ham, and you can see the picture, and you can think very easily about bread and ham. But what do? Okay, you say I have 6 breads, right? How many hams do I need to completely react with, to make sandwiches with the 6 breads? I need 3 hams. How many hams did I start with? 5. I take what I started with, which is 5, subtract what I needed, 3, and I have left over 2. That's the excess. You do the same thing, except you're not looking at ham and bread anymore. Now you're looking at compounds, right? Molecules. So we're going to have, so I'm going to erase all this. Okay, so where do I start with? Or where do I start? I start with the limiting reactant. Right? I start with how many breads I have. And what's the bread, or what's the limiting reactant? The limiting reactant, we said, is the FeCl2. Right, so I'm going to start with we did this calculation already, but 1.4 liters FeCl2 times 0.10 moles FeCl2 per liter of FeCl2. And then I'm going to say, what? In this case, 1 mole of FeCl2 reacts with 1 mole of NH4, NH4-2S. And so that's going to give me 0, except something, right? So that's going to give me 0.14 moles of NH4-2S. That's telling me that I used up 3 hams. I used up this amount of NH4-2S. What's the other piece of information that I need? How many pieces of, well, I need to get there, but in order to get there, I need to know how many I started with. I need to know I started with 5. How do I do that? What's the chemical equivalent of that? I need to find out how many moles of NH4-2S I started with. And we found that already. It's 0.17, right? Because this is 1 to 1. So we can do that, right? So 1.1 liters of NH4-2S, 0.15 moles of NH4-2S per liter of NH4-2S. And then that's it. And that gives me 0.17 moles of NH4-2S. This is used up. This is started with. This is the hams that I started with. This is the hams that I had to use up to make sandwiches with this much bread. And so what's left? What's left is 0.17 minus 0.14 equals 0.03 moles of NH4-2S. You want to do another one? 2.4 liters of 2.1. No, let's not. Yeah, sure. Nah, no. 0.21 molar silver nitrate solution is mixed with 1.5 liters of 0.35 molar aluminum chloride solution find the number of, let's call them molecules, of precipitate. And 2, find the concentration of the excess reactant. Do it. Okay, so what are you going to want to do first? Equation. Do you remember what, and let's call that silver 2, right? So you know that silver, it's AgNO3 2. Is that right? Am I lying to you? NO3 minus. All right, let me just make sure I'm not lying to you. AgCl. Yeah. Or AgNO3, right. All right, so this should be your equation. If you didn't get, because if you get the equation wrong, you're going to get the rest of it wrong. So that's your equation. How are you all doing? Bad. Why are you doing bad? On this test, probably I wouldn't have you write the equation and then do a math problem, because if you get the equation wrong, your math is going to be all screwed up. It's going to be really hard to check. But each component you should know how to do, right? You should be able to write the equation given the, and once you have an equation, you should be able to do limiting reactants. So why are you bad? Number of molecules is just something that comes out of the number of moles, right? You need to find out how much product you can make from the first one, how much product you can make from the second one, right? And then once you have that in moles, you can get from moles to mass, you can get from moles to concentration, you can get from moles to molecules. Right? You're still being asked about how much product you can make. All right. All right. Okay, you ready to go over this? Yes. So, the hint here is that you're asked for an excess reactant, right? So, but whenever you're given information about two reactants and asked something about a product, it's going to be limiting reactants, right? Because if you have information about one product and one reactant, information about the other one, which one do you use? Right? You have to figure out which one you're going to use. So we know something about the silver nitrate. We know something about the aluminum chloride. And we want to find something about the precipitate, which is the silver chloride. Right? And so once we have what we want to find out first, or kind of one stopping point, is moles of silver chloride. Once we get moles of silver chloride, what can we find out? We can use, in this case, Avogadro's number to find molecules. If the question were different or your goals were different, you could use the molar mass to find the mass, the grams. If it was a solution, well, it's not a solution because it's solid, but if you were asked about the other one, you could use the moles and the liters to find concentration. Right? Once you have moles, you can do a lot of things. So we're going to say how much AgCl from the AgNO3 can be made from the AgNO3, and how much AgCl can be made from the AlCl3. And so what are we going to do? We're going to say for the silver nitrate, 2.4 liters times 0.21 moles per liter moles of AgCl per liter of AgCl. And we're going to get, and then we need to say, okay, from the AgNO3, 3 of those give me 3 of these. So 3 AgCl gives me 3, no, I'm lying to you, AgNO3. Right. AgNO3, 3 AgNO3 gives you 3 AgCl. And for that, I think people are getting 0.504 Okay, so we'll keep the extra digit, but it's not really there. Moles of AgCl. Right, and from this one, we're getting 1.5 liters, and the concentration is 0.35 moles of blah, 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 AlCl3 per liter of AlCl3. And the coefficients are different now. The coefficients are 1 here and 3 here. Right, so we're going to get 1 AlCl3 gives me 3 AgCl, and my number here is like 1.7, 1.57, 1.5. Okay, yeah, two significant figures. Moles of AgCl. So which one am I going to use? Which one is the limiting reactant?
Wouldn't it be 1.6?
Is it 1.6? 1.57, right? Yeah, 1.6. Yeah, 1.6. So which one is the limiting reactant? The AgNO3. So I'm going to use this moles of AgCl. And, okay, so it's two significant figures. So it's 0.50 moles of AgCl. How do I get from moles of AgCl to molecules? Avogadro's number. And I'm going to say 1 mole equals 6.02 times 10 to the 23rd molecules. And when we do that, I'm going to get 3.0 with two significant figures, right? 3.0 times 10 to the 23rd molecules. Okay, what about the second part? The second part is the concentration of the excess reactant. This is kind of interesting now, right? So to find the concentration of the excess reactant, remember your breads and your hams, right? I need to find out, yeah?
Aren't we given a concentration?
Not, sorry, moles, not concentration, right? Because concentration and volume, if you have the concentration, you still don't know how much you have because you can have different volumes, right? So we need the moles, right? So we need from the bread and the hams, you need to remember that you need the moles that you start with and the moles that you used up, right? And so which one is the excess? The excess is the AlCl3. So moles, what do you want to do first? Moles we start with? Moles used. Let's start with the moles used up. How do we get the moles used up? We start with the limiting reactant, which is the 2.4 liters of AgNO3 times the 0.21 moles of AgNO3 per liter of AgNO3. And then we're going to use the coefficients, right? Because we have, this is our limiting reactant. How much of this do we use, right? So we got 3 moles AgNO3 gives me 1 mole of AlCl3, or requires 1 mole of AlCl3. And so that's going to give me 0.16 moles of AlCl3 used. Right. What's the moles I started with? It's going to be 1.5 liters AlCl3 times 0.35 moles per liter. And that's going to be 0.53, is that right? Yeah, 0.53 moles of AlCl3 that I started with. How much excess? The excess is 0.53 minus 0.16 equals 0.37 moles of AlCl3 left over. Now it's late and we're tired, but is that my answer? No. What am I asked? The concentration. What's concentration? Moles per liter. So I have moles. Do I have liters? What's the volume? What's the liters? This plus this. So the concentration of the excess equals 0.37 moles divided by 2.4 plus 1.5, which is 3.9. And that's going to be equal to 0.9 something. Someone have an answer for that? That's going to be, calculator, 0.37 divided by 3.9, 0.095. 0.095 moles per liter. See you Thursday.